James Webb Space Telescope spotted a large object about 10 light-years away moving toward Earth. The posts claim that the telescope captured the object changing its trajectory. Music. The James Webb Space Telescope has once again delivered a revelation that challenges expectations and deepens humanity's understanding of the cosmos. When astronomers first turned its gaze toward 3 Atlas, an interstellar object whose presence already defied conventions, the findings suggested something astonishing. 3 Atlas was discovered on July 1 by the NASA-funded Atlas survey. The object was far larger than initial estimates implied. This confirmation has sparked a wave of excitement across the astronomical community. Not just because of the discovery itself, but because of what it reveals about the hidden diversity of bodies drifting through interstellar space. Before we start, smash the like and subscribe buttons for more updates. 3 Atlas was already an intriguing object before Webb examined it. As only the 3rd recognized interstellar visitor to enter our solar system, it carried with it the weight of cosmic mystery. Unlike the asteroids and comets that orbit our Sun and fit within established models of planetary formation, interstellar objects originate from entirely different systems. They are ejected into the galaxy during the chaotic early stages of star and planet formation and then spend millions, even billions of years wandering in the dark between the stars. Each one that passes through our neighborhood is therefore a rare messenger carrying physical evidence of conditions that prevailed far beyond our Sun's influence. For that reason alone, the chance to study 3I Atlas is remarkable. Webb's observations, however, revealed dimensions and structures that no one fully anticipated. Astronomers had already been struggling to pin down the object's size. Early measurements based on ground-based telescopes and preliminary light curves suggested something modest, perhaps no larger than a typical cometary nucleus. That interpretation fit well with expectations since the first 2 interstellar objects identified Oumuamua and 2I Borisov had also displayed features within the range of small solar system bodies. Webb's infrared instruments, however, offered a new level of sensitivity capable of distinguishing faint heat signatures against the darkness of space. What it revealed was that 3I Atlas was reflecting and radiating far more than could be accounted for by a small body. Calculations revised its scale upward, showing that it was dramatically larger than previously thought with a bulkiness that suggested a complex structure. This realization carries profound implications. A larger interstellar body challenges assumptions about what kinds of material can be ejected from forming star systems. Most models emphasize small icy or rocky fragments being tossed out during the gravitational tumult of planetary migration. But 3I Atlas with its unexpectedly massive size suggests that entire planetesimals precursors to planets themselves can be expelled into the interstellar medium. If true, that would mean that the galaxy is populated not just with dust grains and icy shards, but with monumental travelers that silently drift between the stars. The sheer existence of such a large object forces astronomers to reconsider the mechanics of planetary formation and the violence of young solar systems. Another striking implication of Webb's measurements lies in the object's surface and composition. By studying the spectral signature of light reflecting off 3I Atlas, scientists noticed a mixture of features consistent with both icy volatiles and darker carbon-rich compounds. This is unusual as such a combination hints at a history of intense thermal and chemical processes. The fact that these compounds were preserved on an object of this size reinforces the notion that it may have formed in a region of its parent system rich in both ice and complex organics. The presence of organic material on an interstellar body of such magnitude heightens interest in panspermia theories, which suggests that the seeds of life might spread through galaxies via traveling bodies. If objects like 3I Atlas are not rare but common, then the possibility of interstellar exchange of organics and perhaps even prebiotic molecules becomes more plausible. The size of 3I Atlas also plays into questions of detection. Smaller interstellar bodies are difficult to notice until they are already well inside the solar system, and even then they often fade from view quickly. A larger object, by contrast, holds its brightness longer, provides more surface for sublimation of gases, and leaves behind a more obvious trail of activity. This helps astronomers track its motion with greater precision, and offers more time for observational campaigns. Webb's detection and confirmation of its scale serve as a reminder that the interstellar medium may contain many more bodies of significant size. Objects we can hope to detect more reliably as telescopes improve. As news of the measurement spread, the scientific community began grappling with the larger question of population statistics. If 3 is significantly bigger than expected, is it a rare outlier or evidence of a whole category of massive interstellar wanderers? Previous detections have been biased towards smaller objects simply because they are more common and harder to miss. But Webb's revelation forces astronomers to consider the possibility that large interstellar planet decimals may be coursing through space in greater numbers than models predicted. The galaxy then could be a far more crowded place than assumed, filled with silent behemoths moving along gravitational pathways shaped by encounters with distant stars. For planetary defense researchers, this discovery carries another weighty implication. A body of such size entering the solar system poses questions not about collision, since the probability of impact remains minuscule, but about the unpredictability of foreign objects entering our planetary neighborhood. Tracking large interstellar bodies becomes essential not only for scientific curiosity, but also for ensuring that we understand their trajectories and potential effects on comets or asteroids within our solar system. The interaction of such a massive visitor with our Sun's gravity could alter the orbits of local bodies, adding subtle but meaningful complexity to long-term celestial mechanics. The James Webb Space Telescope has proven particularly effective at highlighting the sheer diversity of phenomena that exist in the universe. With its unprecedented sensitivity, it does not simply refine previous measurements, it transforms them. In the case of 3 Atlas, Webb did more than confirm its size. It revealed the inadequacy of our earlier assumptions. Each interstellar object now seems less like an oddity and more like a chapter in a larger cosmic narrative. The newfound size of 3I Atlas reframes our perspective on the galaxy as a place where planetary formation is not just violent but also extravagantly generous in hurling immense fragments into the void.